Lecture 18, Management of Waiting Lines. Waiting lines occur in all sorts of service systems. So wait time is non-value added. So when someone is waiting, you're not adding value. There are some exceptions, like when a new product comes out, something like Apple iPhone is released on a certain date. People like to wait in line. It actually, those waiting lines actually add value, but in most cases, it's non-value added. Wait times range from acceptable to really not acceptable. So you can have short waits in a drive-through, sitting at an airport waiting for a delayed flight. Emergency, you're waiting for the ambulance to arrive, and that wait could be a matter of life and death. So waiting time costs. So one of them is lower productivity. You have reduced competitiveness, wasted resources, and diminished quality of life. So queuing theory is a mathematical approach to the analysis of waiting lines. It's applicable to many environments, things like call centers, banks, post offices, restaurants, theme parks, telecommunication systems, traffic management. All of those are based on queuing theory. So why is there waiting? So waiting lines tend to form even when a system is not fully loaded. One of the reasons is variability. Arrival and service rates are variable. And so a bunch of people arrive and then a bunch of people are not there. I went to Walmart yesterday and there was, on the self-checkout, all the registers were full, and I had to wait to get a register. I get the register. By the time I checked out, all the registers were empty. And I asked the guy, and he said, yeah, it just goes up and down. It's very variable. And then the other thing is services cannot be completed ahead of time and stored for later use. You can't have a bank teller standing there and say, well, I'll go ahead and process the person that's coming in 5 minutes. You can't do it ahead of time. So there's managerial implications of waiting lines. So why are waiting lines a cause for concern? So one of the things is you have to provide waiting space. If you look at a lot of places like Walmart and stuff, they have to have that extra space in front of all the registers that the line can go out to. If in a doctor's office, you can have a huge waiting room. You have to have extra offices or treatment rooms where you can put patients to wait also. And then the obvious one is a possible loss of business when a customer leaves. Every once in a while you're standing in line and it's like, well, they have to get there and they have an appointment and they just don't have time and they have to leave. Sometimes customers leave their cart full and just leave, and now not only did you lose that customer, but you have to put all that stuff away. A loss of goodwill, where someone says, I'm never going there again, I had to wait too long. A possible reduction in customer satisfaction, you get unsatisfied customers. And then the other one is you could disrupt other business operations or customers. So I don't know if you've ever gone someplace and there's this huge line. You get into the line, and then you find out that that line that you're standing in, maybe you stand there for 10 minutes and you get up to the counter and find out, no, you're at the wrong counter. You should have gone to the other counter and there's no line there. So other business operations, other things you're trying to do can just be interfered with by this long line. Waiting line management. So the goal of waiting line management is to minimize the total cost. So this is a curve similar to other curves that we've seen. There are costs associated with customer waiting. And then there's a capacity cost. So if you look at this, it's sort of like the longer a customer waits, the higher the cost. And then here's your capacity cost. You add capacity, add capacity, add capacity. And so if you add these two lines together, you get this total cost. And that minimum point right there, that's the optimum service, service capacity would be right here. Waiting line characteristics. So you have a population source. So the population source is all the people that could potentially show up. So if it's a call center for a bank, then all the customers who could potentially call is the population source. The number of servers or the number of channels, how many people are at that time are serving customers. And then you have arrival and service patterns. So if you're a restaurant, you tend to have people arrive at lunch, people arrive at dinner. There's certain patterns. And then on the service pattern, people at lunch might need to get back to work, so they want a quick lunch. Where at dinner, they want to sit there and talk with whoever they went to dinner with. So it may their service pattern, they're more slow and methodical in the evening. And then the queue discipline. How are you queuing the customers? So here's a simple queuing system. So right here you have the call population. So if this is a call center, everybody who potentially could call the call center, this is their population. They dial in. So these are arrivals. They get a message that says, your call is very important to us. Your approximate wait time is 10 minutes. Well, the words, your call is very, very important to us, and the wait time of 10 minutes, they're sending mixed messages, right? So the wait time of 10 minutes means that your call isn't important. If it was important, the wait time would not be 10 minutes. And then there are the service. You actually have the service, and then they hang up. Now, there's some places they manage this wait line or make it more pleasant where they actually call you back. So it's a 10-minute wait, and they will call you back when it's your turn. So you don't have to sit on the phone and wait. You just, they say, if you would like us to call you back when it's your turn, press 1. So you press 1, you enter your phone number, and now you can go about your business. And 10 minutes later, you get a phone call. And you got to do whatever you wanted to while you were waiting. So here's some common queuing systems. At the top you have a single channel, single phase. So there's all these people are waiting for one server. So that's called single channel, single phase. And then here is a single channel, multiple phase. So here they're waiting for this server, and then you're waiting again. So an example of this is you wait, you get to a doctor's office, and you're waiting to be called. And so they call you, they take you to the room, and they take your blood pressure, they take your temperature, they ask you your questions, they get you all ready for the doctor. And now you are in a new line. It's a virtual line, but there's other people in other waiting rooms that are waiting for the doctor. And then eventually the doctor shows up, and now you're done. So that's an example of a multi-phase queuing system. And this is a single phase multi-channel. So this is an example of a line where you have multiple servers. So you have one line, multiple servers. And this is an example might be something like a Marshall's has a queuing system where everybody's in the same line, and you go through and then you get served. Whoever opens up the next person. So this is a first come, first served queuing system. This chart doesn't show it, but you can also have multiple channels with multiple lines. So there could be a line here, a line here, a line here, similar to what you might have at a Walmart or a grocery store, where you go get in the line, and of course you pick the wrong line, you get all your groceries onto the belt, and the person the eggs are broken, and so someone has to run back and get a new box of eggs for you, and you're standing there waiting. And then here is a multi-channel, multi-phase, where you're in a line and you go to multiple servers, and then when you're done here, you get into another line and you go to multiple servers. So these are different types of queuing systems. So queue discipline is the order in which customers are processed. So the most common one is first come, first serve basis. And then the next one is non-first come, first serve basis, does not treat all customer waiting time costs as the same. So one example is Disney World, where you can buy a fast pass, where you actually pay extra. You pay extra, and now you don't have to wait in line. You go check in at the ride, and they say, well, it's a 45-minute wait, and now you get to go do whatever you want, and you come back 45 minutes later and get on the ride without waiting. So, and in this case, the customer actually paid extra to avoid waiting. So here's some of the metrics that managers typically consider when evaluating waiting line performance. So the first one is real easy, the average number of customers waiting in a line or in the system. So you'll see a manager outside the checkers, and the manager will then page so-and-so, please come check out. So they'll add an extra register, or based on the number of people in line. So if the number of people in line goes up too high, they add more checkers. And then when it goes back down, they take those checkers and they go back out, and they're putting inventory away or doing something else. And then another one is you can measure the average wait time. So measuring the average wait time is a lot easier in a call center, where you can actually measure that. You could have the computer actually measure that wait time. You can also manually measure. You see a customer get in line, and then with a stopwatch or something, and see how long it actually took that customer to get to the front of the line. System utilization. So this is the other side of it. So if customers are not waiting and a server is ready, that server is now waiting. So then the question is, how much utilization of the system is happening? So if you have a 7 or 30% of the time you have servers waiting, then your utilization is 70%. So then there's the implied cost of a given level of capacity and its related waiting line. So how much does it cost for your capacity? And then the question is, what is the cost of a waiting line? How much are you losing because you have a waiting line? And then there's the other one is the probability that an arrival will have to wait for service. So how you can calculate a probability that says, well, the 10% chance that someone will have to wait. So the total cost curve, we talked about this, but it tends to happen in steps because you have one server here. So one server here, two servers, three servers. So if you look at this, you're deciding between these different one server, two server, three servers, and then it's fairly obvious that you would not go with four because four actually has a higher cost than even one, two, or three. So this is sort of a trade-off between one, two, or three servers. So one option might be to go ahead and schedule three servers, but if one of the servers calls out sick, you go with two. So then you're always at two or three. If two of them call out sick, you might want to bring someone else in to get it down. But you could actually do it with one. It's just the cost of waiting is pretty high there. Psychology of waiting. So if you have nothing else to occupy your thoughts, you tend to focus on the fact that you're waiting in line. So if you are focusing on the fact that you're waiting in line, you actually perceive that the waiting time is longer than it actually was. So there's some things that you can do to make waiting more acceptable to customers. So you could, you can have an in-flight snack while people are waiting. You can have them fill out forms while they wait. Doctors are notorious for this one, where it's like, okay, so here's your stack of forms to fill out. Sometimes they say you need to come 15 minutes early so you can fill out forms. Which can be frustrating in its own way when you fill out the same information 3 or 4 times, or you're coming back to the same doctor and they want to know your address and your phone number and your date of birth and all this information that they already have. I like some of the places where you check in at the desk and they print out the information they already have about you and they give it to you and they say, mark on here any corrections that you have. I like that a lot better. And then providing customers information concerning their wait. So if you tell people, like at Disney World, where you actually tell people up front, this is a 45-minute wait. Do you want to get in this line? Or a half hour from here. It helps. Some of the other things that you see in a waiting room, you'll see a TV. Even lines at a theme park, you'll see TVs there to watch. They'll put advertisements up there, or they'll talk about the great rides or different things. So there's things that you can do to actually speed up the wait. So the operation strategy. So you really need to carefully weigh the cost and benefits of your service capacity. So there's some options to reduce waiting time. One is to increase your processing rate. So if your server normally takes 10 minutes to see someone, being able to reduce that by a few minutes, get it down to 8 minutes. Now you can see more. If you're a doctor's office, you could say, well, how can I have this doctor see patients faster? You can increase the number of servers. You can hire more doctors, hire more checkout people. Use new processing equipment or methods. So in this example, it's like in Walmart where you have self-checkout versus a checker. So it depends on how big my basket, how full my basket is. If if I have a reasonably small basket, I would prefer to go to self-checkout because I can just check it out. It takes me a couple of minutes. It may be slower than having someone help me, but I don't have to wait in that other line. And then you can reduce processing time variability through standardization. So if you teach all your checkers to do it the same way, then you find out which checker does it the fastest and why do they do it the fastest. Now you teach everyone else that standard method. And then another option is to shift demand. So if we really like Red Robin, and they have these I don't know, frequent customer program where you put your email in and every 10th burger is free. So I really like that. I get a free birthday burger. But one of the things as part of that is to get your email address. And so they'll send an email and they'll say 10% off on Tuesday, this coming Tuesday. And so what they can do is by doing that, they are shifting the demand to Tuesday where they have less people or less customers. So they're increasing demand on Tuesday and maybe taking it away from Wednesday or Thursday. So we've talked about waiting lines, queuing theory, waiting line management, common queuing systems, waiting line metrics, the psychology of waiting, and the operations strategy.